Good morning students, welcome to you in my YouTube channel Physics Adventure. Today we will discuss a topic potential energy. What is potential energy? Potential energy. Potential means any body has how much potential to do work. So potential energy is the energy which is in the stored form. So we can define definition of potential energy is the energy possessed by a body possessed by a body by virtue of its position, shape is called potential energy. Is called potential energy. So we can say that the energy in the stored form, the energy of a body, the energy of a body in the stored form, in the stored form is also a potential energy. So there are so many examples of potential energy. Example 1, for example, water stored in a dam. A book is placed on the table. So there are so many examples of potential energy. So now expression for this potential energy. There are two types of potential energy. First is gravitational potential energy. First is gravitational potential energy. What is gravitational potential energy? Gravity means the energy possessed by a body by virtue of its position and shape. But gravitational means the height above the surface of earth. Surface of earth is called gravitational energy, gravitational potential energy, and it is denoted by UG. Consider earth, E, denoted by E. If a block is to be raised to a certain height H, if a force is applied on this block having mass M and gravity G, so F is equal to mg. Number 1. We know that work is done by the body is a force into displacement, but here displacement is a height h. So we can say that Fh cos of theta, because both force and h are in the same direction. So Fh cos of 0 degree is equal to F of h. This is what W. But what is F force? Force is mg. So we can write here mgh. UG. This is gravitational potential energy. UG is equal to mgh. Now we will discuss the second point, elastic potential energy. Now second point is elastic potential energy. Elastic potential energy or potential in a spring. Potential in a spring. Potential energy in a spring. Consider a spring is applied with weight mass having mass m. Here x is equal to 0 in its mean position. After some time, if we stretch this spring having weight mass m, so it displaces to some distance x. Why it is this because there is a restoring force, because the restoring force is that force which bring this spring to its normal position. So force is applied in opposite direction and this displacement in this direction. We know that force is directly proportional to the distance x, but in opposite direction. So therefore force F is equal to minus kx. This is equation number 1, where k is a spring constant. K is a spring constant. But there is a restoring force, so some external external force is applied, because external force is always equal and opposite to this force. So we can write here F vector, negative of F vector. So this will become plus kx. So total work done dW, we know that total work is force into displacement dx. Kx, force is kx and displacement dx. Now total work done dW from its origin 0 to x, kx dx. Now integrating on both sides. So W is equal to, k is constant, here is x, from 0 to x is equal to, now integration of this x is x square upon 2. Integration of this x, because we know that integration of x raised to power n is equal to xn plus 1 over n plus 1. So put this 2 outside of this bracket, k over 2, upper limit minus lower limit, x square minus 0 square is equal to, this will become half kx square. This is nothing but a spring constant. So this is the elastic potential energy is equal to half kx square. But if we take F, what is k? Spring constant, k is equal to F over x. This is spring constant. Dimensional formula of force F is mLt minus 2 and x is L. So it will become mL0 T minus 2. That's all.